guys, what we're going to work on today is 5.1, which is the mid-segments of a triangle. So first thing, we need to look at a triangle. And we have a triangle here, triangle ABC, and the length of AB is 8, the length of BC is 10, and the length of AC is 6. Well, what a mid-segment does is it goes through and it connects the midpoints of each of your sides. So I'm going to make a midpoint here and a midpoint on segment AC and a midpoint on segment BC. So I know that D is the middle of BA, E is the middle of segment AC, and F is going to be in the middle of segment BC. So since the whole length of AB is 8, that means the length of DB is 4. And the length of AD is also 4. Well, I can go through and do the middle of each of these. That AE is 3, and the length of EC is 3. The length of BF is 5, and the length of CF is 5. Well, there's something that's special when I go through and I connect these midpoints. So I'm going to do this and you'll see that it actually ends up making 4 triangles. Well, there's something very special about all of these triangles. They end up having parts that are congruent. So I want to go through and see if I can figure out how long is this segment. So I'm going to get my measurement tool here and I want to find the distance or the length of segment DE. Well, notice that that's 5. And say I want to find the distance or the length of segment EF, that's 4. And my distance and my length for DF, that's 3. So notice that each of these mid-segments are half as long as its opposite side. So DF equals half of AC. DE equals half of BC. And FE equals half of BA, and that's going to happen with every mid-segment. The length of the mid-segment is going to be half as long as its opposite side. And that is your mid-segment theorem. The mid-segment theorem says if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and it is half as long. So if D is the midpoint of segment CA, and E is the midpoint of segment CB, then I know that segment DE is parallel to AB and the length of DE is half the length of AB. So let's take this example here. And what are 3 pairs of parallel segments in triangle DEF? So looking at your big triangle DEF as opposed to looking at your 4 little triangles. So our first one, R, is our midpoint of segment ED, and we know that by these little tick marks here. And S is your midpoint of segment EF, and we know that by our 3 tick marks here. So RS is a mid-segment of triangle DEF, which means that RS is parallel to segment DF. Well, we can also do that S is your midpoint of segment EF. Again, we know that by our 3 tick marks. And T is the midpoint of segment DF, and we know that by our 2 tick marks, which means ST is a mid-segment of triangle DEF. Well, ST is parallel to the third side opposite from it, so ST is parallel to segment ED. And our third one, T is your midpoint of segment DF. So R is also a midpoint of segment ED, which means that segment TR is a mid-segment for triangle DEF. So segment TR is parallel to segment FE. So your mid-segment theorem says that mid-segments are parallel to the third side, and also that mid-segments are half as long. So let's see if we can use this information to find the length of segment TU, the length of segment UB, and the length of segment QR. Well, we know that TU is half of segment SR. And SR is 40, so half of 40, the length of TU is 20. What about UB? UB is half of the length of QS, and QS is 50, so half of 50 is 25. And let's look for segment QR. For segment QR, we know that TB is half of segment QR, and so if we substitute in, we'd have 30 equals half of QR, which means we need to multiply both sides by 2, and then we get that QR is 60. So I hope this helps you understand mid-segments.